Welcome to qnawire.
Here we are given a rectangle. It's rotating with an angular velocity of 12 radians per second. We're given the lengths of sides AC and BC, and we're given the direction of VA, and that VA is 2.8 meters per second. So we need to do a few things here in order to find that velocity B. So luckily this will be not terribly complicated for us. So first thing we want to do is find the distance to the instantaneous center of rotation from A. So this will be the length AI. That'll just be the velocity of A divided by omega. When we put the numbers in for that, that's 2.8 divided by 12, which gives us about 0.233 meters. So that is our distance here then. So that would imply that this center of rotation is actually outside of the box somewhere. Just something to keep in mind here, but not a huge deal for the math, at least. We can then calculate the distance between the instantaneous center of rotation and the bottom plate of our rectangle. So that's the distance I prime, which would just be, we're going to take the absolute value here because we don't care about a negative number. So it will just be the total height, which is 0.12 meters. Let me make this absolute value sign a little bit larger just so it doesn't look like a 1 there. And then minus that distance AI, which we found was 0.23 meters, times the cosine of 30 degrees. And that's just finding the vertical component, which I'll highlight here in red. So that distance right there. So this I prime distance, which I'll highlight in green and then write in green, is going to be about 0.82 meters. And again, this I prime is actually, or I itself is actually going to be down below the box somewhere. So actually somewhere over here. Okay, so we have that I prime. Now we want to calculate the distance BI prime. So we can do that in a similar fashion. We have BI prime, which will just be that distance, the entire length of the horizontal distance, which was the length AC, or 0.16 meters, minus this portion, which I'm going to highlight in red here again, which will just be 0.233 times the sine of 30 degrees this time. And this will give us a 0.0435 meters. So once we have those two distances, we can find the distance to BI itself, because now we have the horizontal distance and the vertical distance to it. So the distance BI will just be the square root of these two added together. So I prime squared plus B I prime squared. Take the square root of that to find BI here. It's just the Pythagorean theorem. When we put the numbers in, we get about 0.0928 meters. And I just realized I messed up when I wrote this 0.82 meters. That should actually be 0.082 meters. So just be careful with that. Then next we want to calculate the actual velocity of B. We can calculate the velocity of B by looking at the distance from the center of rotation. crossed with omega. They'll be at right angles to each other, so that part is nice and easy. We know what bi is, we know what omega is, and we find the velocity of point B is then 1.114 meters per second.